Imagine stepping outside on a clear, dark night, far removed from the intrusive glow of city lights. Find yourself in a truly dark, rural landscape where the air is crisp and the silence profound. And then, simply look up. Let your gaze drift upwards, towards the vast expanse above. What you see is a seemingly infinite black canvas, scattered with countless points of light, like diamonds strewn across velvet. A breathtaking spectacle unfolds before your eyes. Each of these tiny twinkling lights, stars, may seem insignificant, but they are actually distant suns burning with unimaginable power. Each star is a colossal burning ball of gas, a churning inferno of nuclear reactions. It's a thermonuclear powerhouse, much like our own sun, constantly converting matter into energy. They appear small and faint only because of the truly vast distances involved. Distances so immense they are almost impossible to comprehend. Consider this. The light from the nearest star beyond our sun, the red dwarf Proxima Centauri, takes over 4 long years to traverse the gulf of space and finally reach us here on Earth. Therefore, when we look at the stars, we're not just seeing them as they are now, but as they were. We're looking back in time. We are seeing ancient light, photons that have traveled for years, decades, even centuries from a distant past. Some stars blaze with an intense blue-white light, indicative of their extreme heat and youth. Others glow with a gentle red hue, signs of aging and a cooler temperature. They range in size from tiny dwarfs, no larger than our own Earth, to colossal giants that could swallow our entire solar system. Our ancestors, without the benefit of modern science, saw them as fixed points of light, unchanging and eternal. But we now know that stars are anything but static. They are born within swirling nebulae, live out their lives and eventually die in spectacular ways, sometimes in violent supernova explosions. In their birth, life and death, they are constantly shaping the universe, seeding it with the elements necessary for new stars and even planets to form. So the next time you gaze at the night sky, take a moment to truly appreciate what you are seeing. Remember, each twinkle is not just a point of light, but a world of fire, a sun in its own right, potentially with planets orbiting around it. And each of these worlds is separated from us by unimaginable distances, distances that dwarf anything we experience on Earth. You're witnessing a cosmic ballet, a grand and intricate dance of celestial bodies that has been unfolding for billions of years. The seemingly peaceful night sky, with its tranquil beauty, actually hides a dynamic, violent universe, a place of constant change and dramatic events. It's a universe filled with objects of staggering size and power, forces that dwarf anything we can create or even imagine. And among them, some stars have grown to sizes that defy imagination, pushing the boundaries of what we thought was possible. These are the true giants of the cosmos, the supergiants and hypergiants that make our own sun look like a mere speck of dust. Their very existence challenges our sense of scale and our place in the vastness of the universe, forcing us to confront the sheer immensity of it all. So, let's embark on a journey to meet one of the greatest of them all, a true behemoth among stars, and explore the incredible properties that make it so extraordinary. Our sun feels enormous, a blazing sphere of energy that dominates our sky and dictates the rhythm of life on Earth. It's easy to think of it as the ultimate standard of size and power, and in many ways it is. Over 1 million Earths could fit inside it, a truly staggering number that's hard to even visualize. Imagine our entire planet, multiplied 1 million times, all crammed within the sun's fiery embrace. Yet on a galactic scale, it's just an average yellow dwarf. A common, garden-variety star in a universe teeming with stellar diversity. It's a humbling thought, isn't it? There are stars that make our sun look like a pebble next to a mountain, celestial bodies so immense they defy our everyday understanding of scale. These aren't just any stars, we're talking about the stellar giants and supergiants, the true heavyweights of the cosmos. These cosmic behemoths are hundreds or thousands of times larger in diameter than the sun. Their sheer size is almost incomprehensible, dwarfing our solar system. Replace our sun with one of these and its surface would extend far beyond Earth's orbit, swallowing Mercury, Venus, and perhaps even Mars. Possibly engulfing Jupiter, turning the gas giant into a swirling inferno, and Saturn vaporizing its majestic rings in an instant. The night sky from any surviving planet would be dominated by a wall of light, an all-encompassing glow that would blot out all other stars. These giants are born from the same clouds of gas and dust as smaller stars, stellar nurseries where gravity sculpts new worlds. But their lives take a more dramatic path, a fast-paced journey fueled by immense mass and energy. They burn through their fuel rapidly, consuming their hydrogen reserves at an astonishing rate, living fast and dying young in spectacular supernova explosions that seed the universe with heavy elements. Their immense size is a sign they're nearing the end of their lives, a visual marker of their impending demise, a final magnificent expansion before a cataclysmic end, a supernova that will briefly outshine entire galaxies. They are fleeting monarchs of the stellar kingdom, burning brightly but briefly before fading into cosmic history. Their existence puts our own experience into perspective, reminding us of the vastness and wonder of the universe. Among these titans, one star stands out as the largest we know, a true leviathan of the cosmos. Meet Ui Scuti, a red supergiant so enormous that it challenges our very understanding of stellar size. Ui Scuti, the largest known star by physical size, lies about 9,500 light-years away in the constellation Scutum. Invisible to the naked eye, it's a variable red hypergiant. Its brightness and size fluctuate as it nears the end of its life. Measuring such a distant giant is a feat of scientific ingenuity, combining brightness, temperature, and distance to estimate its radius. Ui Scuti currently holds the record, but the universe is vast. There may be even larger stars yet to be discovered. We've cataloged only a fraction of the stars in our galaxy, let alone the universe. Ui Scuti is a milestone in our exploration of the cosmos, pushing the boundaries of what we know about stellar physics. It's more than just a big star, it's a beacon of cosmic wonder, but just how big is it? Ui Scuti is a red supergiant, one of the largest known stars in our galaxy. Its radius is truly staggering, stretching out to about 1,700 times that of our Sun. To put that into perspective, imagine the immense scale we're dealing with. The Sun, a star we rely on for all life on Earth, is dwarfed in comparison. If the Sun were shrunk down to the size of a basketball, Ui Scuti, at the same scale, would be a colossal sphere, stretching over 2 miles wide. It's almost impossible to visualize such a difference in size. Now let's try to imagine placing this behemoth in our own solar system. If Ui Scuti replaced our Sun, its surface would extend far beyond Jupiter's orbit, a distance of hundreds of millions of miles. The inner planets, Mercury, Venus, Earth, and Mars would be instantly vaporized, along with the asteroid belt, all swallowed up by this gigantic star. Our entire solar system, with all its planets and asteroids, would fit comfortably inside this single star, with room to spare. It's a truly humbling thought. Light, traveling at an incredible speed, takes just over 8 minutes to reach Earth from the Sun, but that same beam of light would need nearly 7 hours to circle Ui Scuti's equator, highlighting its immense circumference. Imagine trying to fly around it. A commercial airplane, traveling at hundreds of miles per hour, would take over 5 million years to complete a single journey around Ui Scuti. Its volume is almost incomprehensible, about 5 billion times that of the Sun. In other words, you could theoretically fit 5 billion suns inside Ui Scuti, a number so large it's hard to truly grasp. And remember, 1 million Earths can already fit inside one sun. The scale is simply mind-boggling. Only the vast, almost infinite emptiness of space allows such a titan to exist, preventing it from collapsing under its own immense gravity. Ui Scuti, in its sheer size, redefines our concept of what's possible in the universe, challenging our understanding of stellar evolution and the limits of cosmic scale. But size isn't everything when it comes to stars. There are other factors that determine their significance. Let's shift our focus now and talk about mass, another crucial property of stars that dictates their behavior and eventual fate. The biggest star isn't always the heaviest. Ui Scuti is enormous, but its mass is only about 7 to 10 times that of the Sun. The most massive known star is R136A1 in the Large Magellanic Cloud, with about 265 times the Sun's mass. R136A1 is a dense, compact powerhouse, while Ui Scuti is a bloated, puffy giant. Ui Scuti's outer layers are incredibly tenuous, far less dense than air. R136A1, by contrast, packs immense mass into a smaller space. This difference between size and mass is key to understanding how stars live and die. A star's mass determines its life cycle, temperature, brightness, and fate. Massive stars like R136A1 burn fast and die young. Giants like Ui Scuti are swollen with age, not youth. Their size is a sign of their impending end. So, what happens as these giants reach their twilight years? Stars like Ui Scuti are in their twilight years, nearing the end of their lives. For most of their existence, stars balance gravity's inward pull with the outward pressure of nuclear fusion. When hydrogen runs out, fusion falters, gravity wins, and the core contracts and heats up. The outer layers expand dramatically, and the star becomes a red supergiant or hypergiant. Its surface cools and glows red, swelling to hundreds or thousands of times its original size. This enormous size is a symptom of old age, a final grand gesture before collapse. Our sun will one day follow a similar path, swelling into a red giant and transforming the solar system. The story of UY Scuti is a preview of our own distant future. It's a glimpse into the cosmic cycles of birth, life, and death that govern all stars. But the end for a giant like UY Scuti is truly spectacular. When a massive star like UY Scuti exhausts its fuel, fusion stops and gravity causes the core to collapse. This triggers a Type II supernova, one of the most violent events in the universe. The outer layers crash down, rebound, and explode outward, briefly outshining an entire galaxy. The explosion scatters heavy elements, oxygen, carbon, iron, into space, seeding future planets and life. The iron in your blood and the oxygen you breathe were forged in such dying stars. The death of a star is a creative act, recycling material for new generations. What remains depends on the core's mass, a neutron star, or if massive enough, a black hole. A neutron star packs the sun's mass into a city-sized sphere. If the core is even heavier, it collapses into a black hole, where not even light can escape. The cycle of stellar life and death shapes the universe itself. Our knowledge of the cosmos is always evolving. UY Scuti is the largest known star today, but new discoveries or better measurements could change that. Measuring distant variable stars is challenging. Our numbers are best estimates, not absolutes. As technology advances, we refine our understanding and may find even larger giants. The cosmic record book is written in pencil, not stone. Science thrives on discovery and revision. The search for the universe's giants is an ongoing journey. Contemplating UY Scuti forces us to confront our own scale. Our world and even our sun seem tiny beside such behemoths. But this perspective connects us to the universe. The atoms in our bodies were forged in ancient stars. We are made of stardust. We are not separate from the cosmos. We are a way for it to know itself. The existence of stellar giants reminds us of the universe's richness and mystery. There will always be more to discover, more wonders to find. Let the scale of UY Scuti inspire awe and curiosity. Look up at the night sky as a gateway to a universe of unimaginable scale and beauty. Our quest for knowledge is the greatest adventure. Let's keep exploring.